You've seen how to add, subtract, multiply, and divide rational numbers. You have also seen how to evaluate expressions with rational exponents. In this video, we look at several numerical expressions with rational numbers. Let's start with an example. Find the combined areas of these two rectangular shapes. Express as a single rational number. To find the area of a rectangle, multiply the length and width. To find the combined areas of these two rectangles, simplify this expression. 7.75 times 5 plus 6 times 4.25. This simplifies to 38.75 plus 25.5, which is equal to 64.25. Notice that we perform the multiplication first, before adding the products. This is an example of following the order of operations. In other words, we would not have added these two terms first, before multiplying. Let's look at another example. Find the slope of the line that connects the 2 points. Express the slope as a fraction and a decimal. These are coordinates for 2 points on the Cartesian coordinate plane. To find the slope of the line connecting any 2 points, use the slope formula, shown here. Let's look in more detail at how to use the slope formula. Here is a Cartesian coordinate system. The horizontal axis is the x-axis. The vertical axis is the y-axis. Here are 2 points graphed. This point has coordinates x1 and y1. This point has coordinates x2 and y2. To find the slope of the line connecting these 2 points, use the slope formula. You take each value from the coordinates and plug it into the appropriate place in the formula. Now let's use the actual coordinates as shown here. Here is the point 3.5 and 2. To graph it, we move 3.5 along the x-axis and 2 units up. Here is the point -4 and -2.5. To graph it, we move 4 units along the negative x-axis and 2.5 units along the negative y-axis. Let's designate this point as x1, y1, and let's designate this point as x2, y2. Now we plug these values into the formula as shown here. This is y2, and it goes here. This is y1, and it goes here. This is x2, and it goes here. And this is x1, and it goes here. We take this rational expression and simplify it. The numerator and denominator show a subtraction of a negative. These become addition statements as shown here. Combine the terms to get this expression. Divide the numerator by the denominator to get this solution, which is the slope of the line. As you can see, the result is a rational number. As we simplify the rational expression, you'll notice that we perform the addition before the division. We added these numbers first before dividing the numerator by the denominator. Doesn't that go against the order of operations summarized by PEMDAS? In going from left to right, we simplify an expression by starting with parentheses, exponents, multiplication, division, addition, and subtraction. Yet here we performed addition before division. Why? Well, another way to write the original expression here is as a division statement this way. The quantity 2 minus -2.5 is divided by the quantity 3.5 minus -4. Notice that what was in the numerator is now in parentheses, and what was in the denominator is also in parentheses. Because these statements are in parentheses, the expression within those parentheses are done first, following PEMDAS. The P in PEMDAS is parentheses. This is why addition came before division, because the addition statements were in parentheses.